All right, so for today, we're going to be focusing on proportional and non-proportional relationships, and we're going to be talking about something called constant of proportionality. And with constant of proportionality, we're going to be identifying it in different methods. We're going to identify it in word problems. We can identify it with a table or a chart, depending on how you call it. We're going to look at some graphs, and we're also going to look at equations, how to write a proportional relationship in an equation. Okay, but the first thing I just want to review over, we talked about proportional relationships before when comparing ratios. We talked about proportionality with ratios. So remember, at the beginning of the unit, when we were doing the percent proportion, we might have a ratio that was like A over B, and another ratio that was like X over Y. And we knew that they were proportional to each other if we were able to do the cross product, if we were able to multiply A times Y. So A times Y. And then we saw that it was equal to the other diagonal if we multiplied. So if we did X times B or B times X, okay, if those values were equal, those products were equal, then we knew that it was a proportional relationship. So we saw that when talking about proportionality. Now we're going to look at proportionality in some different formats. So some things that's really important to make sure that you keep in mind when we talk about proportional relationships. If something is proportional, if we're looking at a word problem, then we can state that two quantities, right? Remember, we compare different kinds of quantities. Like we might compare hours with miles. We might compare pages with minutes. We might compare price, like a cost of money per item. Okay, those are different kinds of quantities. But we know that these quantities are considered to have proportional relationships. They are proportional if they have a constant unit rate. Okay, and now remember when we talked about the unit rate, a unit rate means that you are dividing two items together. And in this situation, because we're going to be talking about things with graphs and with tables, we're going to use the values X and Y. If you take your Y value and divide it by your X value, you'll get something when X is equal to 1. So when you take Y and you divide it by X, and X has to be equal to 1. Okay, and then some common unit rates that we did talk about. We talked about things like, money over an item. We talked about an item over time. Okay, these are just a couple of different kinds of unit rates that we've seen. So again, if we have a proportional relationship, then when we are looking at the relationship, everywhere that we look at it, it has an identical unit rate, meaning that when we take any Y and divide it by its value of X, so that we can create X equaling 1, that it will be the same for every single part. And it'll make more sense once we start looking through some examples. And if it is not proportional, when we're looking at non-proportional relationships, non-proportional just means that there are different unit rates. So it's not enough to just say that they have a unit rate. It has to be that the unit rate is the same. It's consistent. It's constant throughout the entire problem. If at any point the unit rate is different, then it's not a proportional relationship. Yes, Samara? Not yet. All right, let's take a look at the very first problem here. Andrew earns $18 per hour for mowing lawns. Is the amount of money he earns proportional to the number of hours that he spends mowing. Okay, so when we are asking this, we're asking it in the sense of, is the y value proportional to the x value? Okay, we want to know if there's a proportional relationship existing there. Okay, so the amount of money here, that's going to be our y value. Amount of money is going to be our y. The number of hours is going to be our x. Okay, because we're going to be putting this in a format of y over x. Money is going to be our y. Hours are going to be the x. Make sure you're copying this down. Okay, so we're going to set it up as a table. So in my table, I'm going to put, again, that the hours are my x values, and that the money is going to be my y values. And I'm going to create a table of information here. Okay, we're going to start with the smallest amount of hours, 0. If Andrew works for 0 hours, then how much money is he going to earn? 0. He's going to earn $0. If he does not work at all, he's going to earn no money. What if he works for 1 hour? Will, how much will he make? $18. If he works for 1 hour, he's going to make $18. What if he works for 2 hours? Bubba? 36. He'll earn $36. What if he works for 3 hours? Christian? 54. And we'll do one more. Let's say he works for 4 hours. How much will he make for 4 hours? Jordan? 72. Okay, so we're just making a chart showing every time he works another hour, he gets another additional $18. Right? He worked for 1 hour, $18. When we added another hour, we added $18 and got 36. When he added another hour to get to 3 hours, we added another $18. We got to 54, and so on and so forth. So what we're going to do now is we are going to look at each one of these unit rates. We're going to take each one of the y's, and we're going to put it over the x. Now, there's only one of them that we're going to ignore. There's only one value that we're going to ignore completely. Which one do you think up here is the value that we're going to ignore? What do you think, Santonio? 0. Now, here's why we're going to ignore 0. I want you guys to take a moment right now. In your calculators, I want you to do 0 over 0. Everybody do that. We're going to put 0 over 0 and hit enter. What do we get? Divide by 0 error, right? If you put 0 over 0, you're going to get a divide by 0 error. You're going to get an error because you're not allowed to have 0 as a denominator, as a bottom number. So if x is ever a 0, it's not going to work for you. So we don't bother checking that one, but we're going to check the rest of them. And again, we're going to set it up as y over x. So for this first point, is it going to be 1 over 18 or 18 over 1? 18 over 1, right? Y was 18, x was 1. So we're going to set this up as 18 over 1. And we're going to do it again for the next point. The next point is going to be 36 over 2. And the next one's going to be 54 over 3. And then our last little point, 72 over 4. Okay, what do you think I'm going to do now? I've set them all up. What do you think I need to do now, Brian? Divide. I need to divide all of them. I'm going to do 18 divided by 1. What's 18 divided by 1? 18. What's 36 divided by 2? 18. What about 54 divided by 3? 18. 72 divided by 4? 18. All right, so if you're noticing this pattern here, they are all equal to each other, right? They're all equal to 18. So if they have a constant, that means an equal unit rate throughout the entire thing, then that means it is a proportional relationship. It is proportional, right? It has a constant unit rate. So I'm going to put that in parentheses. It has a constant unit rate. It's an important thing to know. And since it has a constant unit rate, let's go ahead and identify our unit rate. Our unit rate is 18, and it's $18 per what? Per hour. Right? It's always going to be Y per X. Your unit rate is Y per X. Our Y was money. Our X was hours. So it's $18, 18 money per 1 hour. All right, let's take a look at problem 2. Okay, problem 2, it says Uptown Tickets charges $7 per basketball game ticket. Plus, you're going to have a $3 one-time processing fee for the ticket order. So that means that if you're going to go in and you're going to order tickets, you have to pay $3 first before you can start buying tickets. Before you buy any tickets, you have to pay $3. Now, does it matter if I have 1 ticket in the order or 20 tickets in the order? No. It doesn't matter how many tickets are in the order. That one-time fee gets paid at the very beginning before any tickets are placed in your basket. Does that make sense? It's a one-time processing fee for the entire order. You pay it once. So if we have our tickets, we're going to let X equal our tickets, how many tickets we're purchasing. Because remember, Y, your money is always considered a Y value. Money will always be considered a Y value. So if I'm starting my order and I don't have any tickets yet in my basket, I don't have any tickets yet, but I'm starting the process, how much is the process going to cost so far? $3, right? The $3 process fee. So we're starting off with a cost of $3 before any tickets have been added in. Okay, so now I'm going to go ahead and I'm going to start adding tickets in. If I put 1 ticket into my basket, into my cart, how much total am I going to owe? Ethan? Christian? $10. Okay? Why are we going to owe $10? Because we have to pay the fee. We have to pay that $3 fee, and we're going to pay for the $7 game ticket, right? So that $3 fee is in our basket first. Now we're going to add $7 into the basket with it. So we owe $10 if we are just buying 1 ticket. Well, I don't want just 1 ticket. I'm going to go ahead and buy 2 tickets now. Jordan? 17. Here's why. Listen closely. Okay, I had the same thing happen. Phoenix, don't get upset. Same thing happened last period. I had several kids who were like, oh, it's $13. Because they said, oh, we're only adding the $3 fee. Well, the $3 fee is how many times? How many times does the $3 fee happen? 1 time. Did we already pay for the $3 fee there? Yeah. So every time we add a ticket, how much is the price going to go up by? 7. Every time you add another ticket, you add $7 more to your cost. So it's now 17. If we had 3 tickets, what's our cost going to be now? 17 plus 7, which is 24. Good. Okay, what if we add 4 tickets instead? It's now going to be 31. Good. Okay, so here's all of our costs that we see. Now we want to know, is this going to be a proportional relationship? So again, it's always going to be blank over blank. It's Which one goes on top, X or Y? Y. Y is always on top. We're always going to put Y over X. Are we going to do 3 over 0?
No.
No. Remember, do we do over 0?
No.
No. Because what are we going to get if we do that? Divide by 0 error, right? If we do 3 over 0, we're going to get a divide by 0 error. Okay, so we're going to go to this one. We're going to go 10 over 1. We're going to do 17 over 2. We're going to do 24 over 3 and 31 over 4. Right? All of this information we're getting from our table. And now we just have to divide. We just have to divide. 10 divided by 1, $10. 17 divided by 2, 8.50. 8.5 or 8.50. 24 divided by 3, 8. 31 divided by 4, 7.75. Okay, so here's the thing. Are these constant? Are they the same? No, they're not the same. These are not equal to each other. They are not equal. So since they're not equal, it's not proportional. The relationship is not proportional. Not equal, not proportional. Okay, we're going to do one more example together. We're actually going to skip problem number 3. I want to do problem number 4 with you guys because I think that problem can get a little bit confusing with the fraction involved. So we're going to do that one together, and then you'll do the other 2 examples on your own. So let's go ahead and flip it on over to the next page. Take a look at problem 4. We're going to create our table. Always got X on the top, Y on the bottom for our table. Okay, a recipe for fruit juice calls for half a cup of sugar to be combined with 2 quarts of juice mix. We want to know, is the sugar proportional to the juice mix? So remember, this first value is going to be our Y. The second value here is going to be our X. So X is going to represent our juice. Y is going to represent our sugar. Okay, if I don't have any juice, do I have any sugar? Nope. No juice, no sugar. So now I'm going to look at the only numbers they gave to me. They said half a cup of sugar. So, okay, sugar, half a cup. I'm going to go ahead and put half. And it's 2 quarts of juice. So I'm going to put 2 up here. 2 juice, half of a sugar. Well, I went from 0 to 2, so I counted by 2s. So I'm going to count by 2s again. I'm going to go to 4 juice. If I have 4 quarts of juice, how much sugar will I have? Not 8. I'll have what? Somebody said it. 1. We'll just have 1. We're just going to have 1 cup. I'm going to count by 2 again. I'm going to go to 6 cups or 6 quarts of juice. 6 quarts of juice. How much sugar will I have?
1.5.
1.5. Right? 1.5. See, if I'm counting here by 2s, then I'm counting here by halves. Right? I went from 0 to a half. Add another half, I go to 1. Add another half, I go to 1.5. If I were to do it again, I would go to 2, right? 8 and 2. I'm not going to show all of them because I want to get us working real quickly here. All right, let's take a look here. Not going to count 0, 0 because I don't want to deal with an error. So we're going to put a half over 2. A half over 2. That's going to come out to 0.25. We're going to do 1 over 4. That's going to count to 0.25. And then we're going to do 1.5 over 6. And guess what? That comes out to 0.25. Are they equal? Yeah, so that means it's proportional. We are dealing here with a proportional relationship. Okay, it's proportional when we have a unit rate. Our unit rate is 0.25 cups of sugar per juice quart. Okay, it is a proportional relationship. 0.25 is our unit rate, our constant unit rate. Okay, I want you guys to do problem 3 and problem 5. Problem 3 and problem 5. Okay, so for problem number 3, Anna walks 6 miles per day. We want to know if this is proportional, if the miles is proportional to the days that she's walking. So days is going to be our x, miles is going to be our y. So if we walk for 0 days, how many miles will she walk? 0. If she walks for 1 day, how many miles? 6. She walks for 2 days, 12. 3 days, 18. 4 days, 24. Okay, we're going to stop it right there. So now we're going to set it up. Again, y over x, and we ignore this first one. We're going to do 6 over 1, which is going to equal 6. We're going to do 12 over 2, that equals 6. Oh, they're equal. 18 over 3, 6. 24 over 4, 6. Okay, so they're all equal to each other, so that means it is a proportional relationship. Okay, we are dealing with a proportional relationship, and our unit rate is 6 miles per day. 6 miles per day for our unit rate. All right, let's take a look at problem number 5. For problem number 5, Josh has $120 in the bank. Each week he deposits another $20. So we want to know, is the money proportional to the weeks? Okay, so before he starts doing anything to his account, how much money is he starting with? At 0 days he has how much money?
20.
Not 20, 120. He has 120 in the bank right now. He hasn't done anything to it. He's just starting off with 120 in the bank. Now, starting now, every week he's going to deposit $20. So when the first week is over, he's going to put $20 into the account. So how much is he going to have now? 140. After the second week, now how much is he going to have?
180.
Not 108, 160. 160. Right? Add another $20. After 3 weeks, it'll be 180. Okay, after 3 weeks, it'll be 180. And if you did 4 weeks, $200, you could go on and on. But we're going to stop right there and do our rates. Okay, we're going to ignore 0. Ignore the 0, 120. We're going to do 140 over 1. 140 over 1 is 140. Then we're going to do 160 over 2. That's going to come out to 80. Those are not equal to each other. Okay, then we're going to do 180 over 3. That's going to give us 60. That's not equal to anything. So is this a proportional relationship? No. That is non-proportional. Okay, so we're going to stop here.